In many countries, including the United States, we are striving to increase our use of renewable energy sources to reduce our dependence on fossil fuels and curb the negative effects of climate change. In many states, including Minnesota, one renewable energy source of importance is wind power. In 2020, about 68% of the renewable energy sources used in the United States was from wind power. For that same year in Minnesota, about 81% of the renewable energy sources used was from wind power. We can clearly see that wind power plays an important role in our clean energy use. Comparing the use of all resource types in Minnesota, wind power comes in at about 22% of the energy mix, with only coal and nuclear power ahead of it. Although wind power sounds like a simple, clean energy resource that can aid in our shift to more renewable resources, we first need to consider the production costs, the carbon footprint, and the potential of wind towers used to generate wind power. During this analysis, we will be breaking down production costs of different types of turbines, comparing wind tower carbon emissions to other sources such as petroleum and natural gas, and we will be looking at how wind could potentially replace fossil fuels in the transportation sector in the future. The production of wind towers heavily varies on many different things, from the materials that are used to make the tower to the type of engine that runs it. This can greatly change the cost of production. There are two main types of wind towers that create electricity, which are gearboxes or direct drives. Gearboxes and direct drives are the generators that increase the rotations per minute of the blades by either using a series of gears that turn a second blade faster in the case of the gearbox, or by using magnets that propel the blades as they pass by in the case of the direct drive. There are many different things that can affect the price of wind turbines. In the United States, on average, the cost for a gearboxed wind turbine is $2.5 million, whereas a direct drive wind turbine averages from $2.7 to $3 million. This price also includes the overall maintenance of the wind turbine as well. There are a lot of factors that can change the production of a wind turbine. Some of these include if it's onshore or offshore, the size of the parts, like how long the blade is or how tall the tower is, and the kilowatt capacity. So, how much energy do wind turbines actually make, and what's the return on the investment? Well, a study done in the United States in 2019 says that a 2.5 megawatt wind turbine running at an average capacity of 35% can make $153,300 a year, which means that it would have to run for 16.3 years at this capacity to make as much money as it cost. Most wind turbines can live for over 20 years. Even though wind towers are powered naturally and mostly emission-free, they still produce emissions during construction, repairs, and other small contributing times. To determine the amount of carbon dioxide produced by a wind tower, a life cycle assessment is conducted, which assesses the amount of carbon dioxide produced from the initial gathering of materials to make the wind tower all the way to its end of life when it needs to be decommissioned. Wind towers typically last for 20 to 30 years, and the life cycle assessments use a 20-year lifespan to evaluate the carbon dioxide emissions. There have been many life cycle assessments of wind towers done throughout the years. In this assessment, we'll focus on a collection of 44 studies. The average carbon dioxide emissions of wind towers in these studies is 19 grams of carbon dioxide per kilowatt hour, which we will use to compare to the amount produced by coal, natural gas, and petroleum. These are being compared against the data collected by the Energy Information Administration, which states that coal produces roughly 1,002 grams of carbon dioxide per kilowatt hour, natural gas produces roughly 412 grams of carbon dioxide per kilowatt hour, and petroleum produces roughly 966 grams of carbon dioxide per kilowatt hour. Comparatively speaking, wind towers stand out far above the competition in terms of the amount of their carbon emissions. Wind towers are roughly 53 times better than coal, 51 times better than petroleum, and 22 times better than natural gas, making them a great alternative for a better, more clean environment. Since wind energy has much lower carbon emissions than fossil fuels, it is important to look at how it can replace fossil fuels in real-world scenarios. Recently, Taiwan completed a comprehensive study of highway traffic and the location of wind turbine farms. The goal was to determine if renewable energy sources can be used to charge electric vehicles and which highways have more traffic, thus needing a higher production of energy. Taiwan is a country that has invested heavily in wind energy recently, with the implementation of large turbines in the ocean, as it is an island country. However, this is not the only location where wind turbines are stationed in the country. Building turbines close to highways would cut the energy transportation cost. Using wind energy to power transportation would make electric vehicles more cost-effective than they currently are, and because of new offshore wind farm development, Taiwan will have excess energy to use for other purposes during times when car travel is not at its peak volume. One issue with wind energy is that it is hard to store for long periods of time. Wind energy, water, and captured carbon dioxide can be synthesized to form carbon-neutral gasoline, jet fuel, ethanol, and propylene. This is currently only a simulated process and is called wind fuels. It has been computed that wind energy can electrolyze water into hydrogen and oxygen. This breaks down carbon dioxide to carbon monoxide, and the carbon monoxide can then be mixed with hydrogen in a hydrocarbon reactor. The future of wind energy is quite promising, with market growth and designs expected to improve greatly over the coming decades. Compound annual growth rates, which is a percentage that tells us the yield of an investment or sector on an annually compounded basis for total wind energy between 2002 and 2017, have been quite high in the following countries. The compound annual growth rate for the world as a whole in that time span is 15%. Between 2008 and 2018, the offshore wind energy market has grown 30% annually. Onshore wind energy is the cheapest form of wind energy, but the difference between it and offshore is slowly declining. Fixed bottom offshore is cheaper itself than floating offshore, which is the most expensive wind generation method. There is a potential for 24 to 30% cost reductions by 2030 and 35 to 41% reductions by 2050 from various technological improvements. Improvements to blades, drive chains, gearboxes, and less expensive and more efficient installation plus upkeep are advancements that could be seen in the near future, as well as more eco-friendly batteries and capacitors. Research into offshore air profiles and better designed land, air, and water measurement systems would improve locating the best regions for farm development. Some work is being done with vertical and even airborne turbines, but the two aren't especially cost effective, and they also have several risks and drawbacks at this time. As many countries are beginning to switch to more renewable resources, wind power has become an option that can satisfy this need. Although wind towers are expensive to make, the long-term benefits of wind towers outweigh these costs. This is because wind towers have a smaller carbon footprint compared to coal, natural gas, and petroleum, and also have a lifespan of about 20 to 30 years. In the future, wind power would be more practical to produce if it was combined with other renewable energy forms, such as electric vehicle charging and carbon dioxide recycling. In the next 10 to 30 years, wind towers could also potentially see cost reductions in their production due to advancements in technology, which is something to consider. In the end, wind towers could greatly benefit our goals of reducing greenhouse gas emissions and curbing the effects of climate change.